Today we're going to continue looking at section 5.5. We're going to be finding missing values using properties of kites and trapezoids. So let's talk about what those shapes are. So a kite is a quadrilateral in which two disjoint pairs of consecutive sides are congruent. So notice this is the first quadrilateral since we talked about parallelograms where I don't use the word parallelogram in its definition. That's because a kite is not a parallelogram. So those 5 properties of a parallelogram are not going to happen here with a kite. So if you kind of remember the idea of what a kite looks like, it is 4 sides because that's what makes it a quadrilateral. And when it says that 2 disjoint pairs of consecutive sides are congruent, it means that not any 2 sides that are consecutive are congruent. It means that we have 2 specific sides right next to each other that are congruent, and the other 2 pairs of consecutive sides are congruent. But notice like the top 2 sides wouldn't be congruent because not all 4 are congruent. A trapezoid is a quadrilateral with 1 pair of opposite sides parallel. So once again, it doesn't use the word parallelogram, so it's not going to be dealing with those 5 properties of a parallelogram. A trapezoid would look something like this. Once again, if it's a quadrilateral, it means that it has 4 sides. But in the definition, it says 1 pair of opposite sides are parallel. So hopefully we notice that in this case, it would be the top and the bottom that are never going to intersect. Okay, we call those sides that are parallel, we call those the bases. So anytime you hear the word base when we're talking about a trapezoid, it means the sides that are parallel. And then we have an isosceles trapezoid. So an isosceles trapezoid is a trapezoid in which the non-parallel sides are congruent. Okay, so we know that a trapezoid has 1 pair of opposite sides parallel, but now for it to be isosceles, we have the other 2 sides that are congruent. Think about like an isosceles triangle. A triangle that has at least 2 sides congruent would be isosceles. So here, 2 sides that are parallel are never going to intersect, but then the other 2 sides, in this case, they would have to be congruent. All right, so once again, I would highly suggest that you go to the extra resources and you pull up that, that worksheet or that checklist with all of the properties of the quadrilaterals, because we get to use that when we are solving these problems. So it says we are given that the quadrilateral below is a kite. We're going to find the value of x, and then we're going to find the perimeter of PSRQ. Okay, so there's a lot of information going on in this, but when we're talking about a kite, remember the definition is that we have 2 disjoint consecutive sides congruent. Okay, so obviously this 5x minus 1 is not going to be congruent to the 8x plus 3, but it's going to be PS and PQ that are the consecutive disjoint sides congruent, and same thing with the SR and the QR. Okay, if you look at that checklist of properties, one thing that you'll notice is that the smaller diagonal is always going to end up being bisected. So SQ is a diagonal that's smaller in length than PR. So this is the diagonal that's being bisected. So really, that's the information that we're going to start with in order to solve for x. So I'm going to be able to set x plus 4 equal to 3x. So then to solve for x, I'm going to subtract x from both sides. 4 is going to equal 2x. When I divide by 2, I get x to be 2. So that is half of my answer. It said find the value of x. Now what it's asking for is for us to find the perimeter of our kite. Well, like we know, we have 2 different sets of congruent sides in a kite. I'm giving you 5x minus 1 for one of the 2 sides, and then 8x plus 3 for the other. So I'm going to substitute 2 in to the 5x minus 1 as well as the 8x plus 3. So 5 times 2 is 10 minus 1. That gives me a length of 9, not once but twice. 8 times 2 is 16, and 16 plus 3 is 19, so those two sides. So our perimeter is then us adding up all 4 sides. So we're going to take 9 plus 9 plus 19 plus 19. So when I add those 4, we're going to end up with a perimeter of 56. All right, we're given an isosceles triangle, KEVI. If we notice, we are given that one of our diagonals, KV, is a length of 15. The other diagonal that's given, IE, is given to us as an expression. It's 2x plus 8. If you look at your checklist, you'll see that we are dealing with diagonals, and in an isosceles trapezoid, diagonals are congruent. So to solve for x, I get to set 15 equal to 2x plus 8. So I'm going to subtract 8 from both sides. That's going to give me 7 to equal 2x. And then I'm going to divide by 2. And so you can leave it as 7 halves. Or if you want, it is a nice decimal. I wouldn't have a problem with you writing that. But if it was a repeating decimal, then just leave it as that fraction. But obviously you want to reduce fractions down to lowest terms. Okay, so that's us solving for x. The other thing it was asking for was the length of IE. Well, honestly, you don't even have to substitute in 7 halves or 3.5 into that expression, because remember, the whole point is that the diagonals of an isosceles trapezoid are congruent. I already gave you KV to be 15, so that's also the length of IE. So you could have actually found that first before we even solve for x. All right, let's look at another kite. So JKLM is a kite. I know that KN is represented as 3x. I know that angle LNM, this right here, is going to be 9x plus 9. We want to find the length of KM, which is that entire diagonal. Okay, so if we are looking at kites and the properties of a kite, I'm talking about angle LNM. That is an angle that's being formed by the two diagonals, and one of the properties is that the diagonals are perpendicular. So perpendicular means that we're forming right angles. So not only do I have that angle as an expression of 9x plus 9, but I also know that it is 90 degrees. So when I have two things representing the exact same angle, that means I get to set those two things equal to each other. So then I'm going to subtract 9 from both sides. That gives me 9x to equal 81. And then when I divide by 9, I get x to be 9. That's not what I want, though. I want the length of KM. Well, notice that I'm not giving you an expression for KM, but I am giving you an expression for KN. If we think back to the other kite problem, remember the smaller diagonal is always the one that's being bisected. So those two little pieces are congruent. And if KN is 3x, so is MN. So that means that KM is really 3x plus 3x, so that really is 6x. And now I know that x is 9. So 6 times 9 is going to get me that length, and so that's going to give me 54. All right, let's look at this problem. Once again, we're dealing with a kite. I'm telling us that ST is x plus 5. I'm telling us that TP is y plus 9. SW is 2y plus 7. And WP is 3x minus 10. We want to find the perimeter. So in order to find the perimeter, I need to know what the lengths of the sides are so I can add them up. But notice that how the picture is marked, I see that my different congruent pieces, one of them has an X and one of them has a Y. So this means we have to set up a system. But I know based off those markings that we've got congruent segments. So X plus 5 equals Y plus 9. I know that 2y plus 7 is going to equal 3x minus 10. So there's my two equations to start my system. I'm going to get it into the elimination mode. So I'm going to subtract y over to the other side, and I'm going to subtract 5 over to that side. In the bottom, I'm going to subtract the 3x, and I'm also going to subtract the 7. So if I'm looking then at my new top equation, we'll have x minus y, and that's going to equal 4. If I look at the bottom equation, we will have negative 3x plus 2y, and that's going to equal negative 17. So now I want to solve for x and for y so then I can get the perimeter. I don't have enough information yet to quite eliminate anything, but in this problem, we have it pretty easy. Both the x and the negative 3x, they're already opposites. I can very easily turn a 1 into a positive 3. With the y's, I've got a negative 1y on the top and a 2y on the bottom. I can very easily turn negative 1 into negative 2. So either way, we could eliminate either one of those variables. So I think I'm going to eliminate the y's. That means I'm going to multiply the top equation by positive 2. So that's going to give me a 2x minus 2y to equal 8 on the top, and negative 3x plus 2y still equals negative 17 on the bottom. So when I'm adding these, I'll have a negative x to equal a negative 9. And then divide by negative 1, and I get x to be positive 9. Remember, it's okay if x was actually negative, only if then when I plugged it in, I can't have my segments end up being negative lengths. That's no such thing. There is no such thing as a negative length. Okay, so now that I know what x is, I can go back to any of my equations and I can solve for y. Notice that if I go back to the original top equation of x minus y equals 4, I can now do 9 minus y to equal 4. That means I'll subtract the 9 from both sides. That gives me negative y to equal negative 5, and then I'll divide by negative 1 to get y to be positive 5. So now that I have that, I can plug those in. So notice that if I take 9 plus 5, that's going to give me a length of 14. And that's the same thing if I did 5 plus 9, which makes sense. Those should be the same length. In the bottom, I could do 3 times 9 minus 10. Well, 3 times 9 is 27, and 27 minus 10 is 17. That's the same thing if I do 2 times 5 and add 7. That will also get me 17, which makes sense. So my perimeter is just adding up all 4 sides. So I want to add 14, 14, 17, and 17 together. So let's see what that is. That is going to give me a perimeter of 62. Okay, so that's us using properties of kites and trapezoids.